Now in this video, we come back to a circuit I've been looking at quite a bit in my recent videos. So we have here a constant current source when we have a load across here, and we can measure the current through the resistor. That will become a load. But in any case, we have here a voltage that we set, in this case with the zener diode. However, the PNP transistor here, the 2N3906, all bipolar junction transistors, they drop a diode voltage from base to emitter. And so I taken the voltage that goes across this transistor once it starts conducting, and adding the voltage with a rectifier diode here, which should have about the same voltage gain as the voltage drop from base to emitter. And so they should cancel each other out. We should get the voltage that the zener diode wants to be set across the resistor, and that will set the current. So this video, we're going to look at what's going on with the rest of the current. So I'm going to oops, didn't mean to go to 24. I'm going to go down to 10 volts to start off with, and we're going to take a current reading. And so I'm going to set the meter to measure milliamp current. Pretty simple. We got the milliamp there, and the red probe stays where it is at all times other than high current. If you got to measure high current, you got to move the red probe. But in any case, we're going to complete the circuit. I have the probes backwards, but there you can see we have pretty much spot on 8 milliamps of current right there. It'd be nicer if it was a little above 8, but it's pretty much spot on 8 right there. And so changing the load, for the most part, will not affect the current that is flowing. So we just added, there really was no load, now we have an LED, and current's holding pretty steady. But again, we're only dealing with 10 volts as I showed earlier, and we have 8 volts across that resistor. And so now we add another LED, and we ran out of voltage basically. And that's what this video is going to be, looking at the voltage. So I'm going to increase the power supply voltage, and the circuit will start working as intended again. There you can see we got 8 milliamps of current, and there's more current flowing through the zener diode because we are using a higher voltage, and so it will block a little bit more voltage. So it's pretty nice now at 14 volts. You can see the 8 milliamps of current. So this video, we're going to look at what's going on with voltages. So I'm going to leave this where it is. We don't need to look at that anymore. We can just focus on the circuit and the multimeter. So from now on, we are interested in voltage. I'm going to set the meter to measure voltage right there. And so first, let's do the same thing now. We will plug this. We saw this holds 8 milliamps of current really nicely. I'm going to grab this green jumper here, and we're going to look at what's happening with that voltage. And so I got the jumper going there. Now current's flowing through here. We need that whole current path to hold that voltage across that resistor to get that buildup. So we can look at the rail. There we have 14 volts right there. If we go across the resistor, as I said before, we get the 8 volts that the zener diode set. So this is a 1 kilo ohm resistor, 1000 ohms of resistance. Every volt across it, it will let through 1 milliamp of current. That's just basic Ohm's law. And so the transistor does that for us automatically. So what happens to the rest of the voltage? We got 14 volts at the power supply, 8 across here. That leaves about 6 milliamps, or about 6 volts, I should say. So now we're going to go across the transistor. So I'm at the emitter up there. This is a PNP transistor, 2N3906. The collector is down here. There you can see we got pretty much spot on 6 volts right there. There's probably a little bit of voltage lost in resistance in the wires and whatnot, but in any case, that's close enough to 6 volts right there. So it has the rest of the voltage. So what happens when there's an LED? So LEDs, we know, they block about 2 volts. These red ones, I gotta make sure the long lead, the anode, is towards the positive side. I almost stuck it in there backwards, and it would not have lit up. But in any case, we also have to move this jumper too. We were bypassing the LED. So now the LED is lit up. We'll see that thanks to the circuitry, we still have 8 volts across the resistor. The transistor is doing whatever it can to keep that voltage. Now we're going to go across the transistor and the LED. So I'm at the emitter and then down to the cathode of the LED. There you can see that 6 volts again, and pretty reliably. So now I'm going to bypass the LED when it comes to the voltage measurement. You can see we have, once I get a good connection, about 4 volts across the transistor, and then we'll come just measure across the LED, and it's pretty much 2 volts right there. So the LED took 2 volts away from the transistor to hold 8 volts at the resistor there. So now I'm going to move this down one spot, and we're going to do the same thing with another LED. So the voltage gets divided up as needed amongst all these series components to make sure that the resistor there has 8 volts across it. So we'll do that quick, and I'm going to end the video after this, but there you can see we got 8 there. So we're almost done. We'll have 6 across the load, as we just saw. So that's emitter of the transistor through the transistor, and then through 2 series LEDs there. You can see we got 6 volts. We'll skip past one of the LEDs. Now we got 4, and then now we got 2 across the transistor. So each one of these is splitting up the voltage about evenly. But the main takeaway is we're holding the voltage steady across the resistor, which is setting the current. And so that's how this circuit works when you look at the voltages there. So if you want to get into more detail about all the reasons why the voltages are getting split up and stuff like that, that's what the textbooks are for studying transistors. This video is just a demonstration of what's happening, which the textbooks generally do not demonstrate very well, in my opinion. So I figured I would make a video on that. And if you want the more tedious explanation of all of it, go to the books. Read an electronics book about transistors, semiconductors and stuff. They'll give you more detail. But in any case, hopefully you still found the demonstration enjoyable. Thanks for watching. I will see you in the next video.